This is the scenario crash measurement. You can watch this video by clicking here. The purpose of this activity is to give you concrete experience necessary for you to thoroughly understand and explain the concepts of measurement, employ various techniques of measurement, objects, and apply the concepts in solving practical problems. As a law enforcement officer, you may be required to investigate traffic crashes. Traffic crash investigation student textbook can be accessed using this link above. You will measure and record your data using a rectangular coordinate system as described in the TCI textbook. We're going to measure, we're going to graph, and then we're going to measure distances using rectangular coordinate system. The video that you see pictured on the right here is of Kevin Halke and Sarah Scoville as they measured with the help of Sean Emberts the intersection, and then Sean made a video of it, and you can watch that video. It will help not only with the explanation, but it will also help you with the actual measurements down below. For traffic crashes, we measure using USCS systems since speed is measured in miles per hour. We will perform all measurements from the origin and then transfer those measurements to points on the rectangular coordinate system. Dimensions are calculated by finding the difference between the points on the coordinate system. This quote is from the TCI textbook. The coordinate method requires two measurements or coordinates to locate each spot. These measurements must be made from two permanent, easily identifiable markers. Anyone returning to the collision site should be able to reestablish these landmarks. You must select your landmarks before starting to measure. And so, for purposes of our experiment, we measured from the outside northeast corner of Preston Road and Campus Drive. This is a Google Maps image of the situation. Here you can see the sign. And then up here on the lawn is where we place the camera that is in our video. And then I'll put a picture right here, and you'll be able to see the video of the intersection. Here's a map that I made of the intersection, and you can see the spot in the ditch in red there where folks enter the ditch. Each of the points A, B, C, D, E, F, G, and H we measure from the origin, which is a X that I made in the dirt on the northeast corner of Preston Road. So the first thing that you have to do is you have to find the location for each of these. So if you notice, I put in one of these is the x-axis, one of these is the origin, and one of these is the y-axis. You just have to figure out which is which. Okay, now, for each of these measurements, you can watch this video to get them. Otherwise, you could also look at the pictures that I have here, and I'll show you. So from the origin to the east side of Preston Drive, so if you look at this picture here, you'll see the tar starts right here, and it appears to be 2 feet 5 inches. So I return to the scenario, and I put in 2 feet 5 inches. And so you do that for each of the other points here. And if you notice, like for instance, this. All right. So anyway, you see the different coordinates for each one of these. The ones I'd like you to pay attention to is this one, this measurement, the third measurement that we make, gives you the x coordinate of both C and E. So that gives you both of those x coordinates. And then down here at the bottom, you get the x coordinates of F, G, and H at the same time also. F and G and H. They're all next to each other. The other thing that I'd like you to notice is that point A has a y coordinate of 0, and then point B also has a y coordinate of 0. So you'll fill those in. Well, then if you notice here, point A's x coordinate is right here. So when we get down below, we put point A's x-coordinate into this spot also. Then, when you get done, each one of those points should appear on the correct spot on this graph. When you get all of the points in, and you should be able to see the outline of the road here, and they should all match up correctly. So you'll have to give that a shot and see how you do. The last thing we're going to do, so we got the x coordinates here. The measurements you just made can be translated into coordinates. Point A is assumed to be on the x-axis, so its coordinates address would be 2 feet 5 inches and 0 along the y-axis. Okay. So we've got those graphed. Now, find the distance between points. So the width of Preston Road, well, to find the width of Preston Road here, we need to get the other measurement, which is the measurement for point B. So let's go up here and let's do B just so that you can see the picture. And if you notice here, it's right at 29 feet, looks like about 1 inch. So we put in 29 feet 1 inch here, and we have to put it here also, 29 feet 1 inch. Okay, now to find the distance between those two, we're going to use our calculator to calculate that distance. So it's I'm going to use the fraction key on our calculator, 29 feet 1/12 of a foot, because that's 29 feet 1 inch. Subtract another mixed number, 2 feet 5/12, and we get shift S to D, because we want it in the mixed number form, 26 feet 2/3 of a foot. So we would say that that width is 26 feet. And now we have to take that 2/3, 2/3 times 12, because there are 12 inches in a foot. And so we get 26 feet 8 inches is the width of Preston Road. So there you see how you do it. And you do the same thing down here below. Measure the east, west, and north, south dimensions of each of these curves, because if you notice, they aren't, the curves aren't circular, they're more elliptical shape. When you get done, you will have 30 points up here for your score. Talk to you later. Bye.